Good morning, everyone. Today we're going to start with lesson 8 of chapter 2, which talks about two variable inequalities. Okay, so in this lesson we're going to graph a linear inequality that has two variables. Okay, a linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. This line is the boundary of the graph. So this line is the boundary of the graph. It's called the boundary. How to get the boundary? We're going to have an inequality, then we're going to assume some values for x and find the answers of them for y. Then we're going to plot the points over here and then make a line. The boundary separates the coordinate plane into two half planes, one of which consists of solutions of the inequality. Okay, so here you see that here's a shaded part or a yellow part. The yellow part or the shaded part that we have is the part that has the solutions for this inequality. Now to determine which part to shade, for example, if I have this line, how shall I know which part to shade, this part or this part? What we're going to do, we're going to have a test point that is not on the boundary. Check whether that point satisfies the inequality. If it does, shade the half plane that includes the test point. If not, shade the other half. The origin 0, 0 is usually an easy test point as long as it's not on the boundary. So how we're going to know? We're going to substitute a point. Generally they use 0, 0 if it's not in the boundary. So we're going to substitute, for example, 0, 0 into the inequality. We're going to have y equals 0 and x equals 0. Then we're going to check if the inequality is correct or not. If the point satisfies, like if the point satisfies the inequality, you're going to shade the part with the point. If not, you're going to shade the other part. So let's start with the problem, so it's going to be easier for us to understand. What is the graph of each inequality? Okay, let's see, or let's solve it together. Okay, so now they gave us this point. They already gave us the graph of the line here we have, or the boundary. How they graphed it, you're just going to have x and y values as like -1, 0, 1, 2, and you're going to substitute the x values over here to find the answer of y. Then you're going to plot the points and make a boundary or make a line. Okay, now we have one more point to know. If we have an inequality with the signs greater than or equal, we're going to graph the line here as a dashed line. If we had greater than or equal or less than or equal, if you have this sign or this sign with the equal, you're going to graph it as a line without dashes. Okay, just put this point in your mind. And now let's check which half shall we shade, or which half is going to be the solutions of this inequality. So what we're going to do, we're going to substitute a point. Generally we use 0, 0 into the inequality. Okay, so let's substitute 0, 0. It's going to be as 0 greater than 3. Instead of x, we're going to have 0 minus 1. So it's going to be 0 greater than 3 times 0, 0, 0 minus 1 minus 1. Now, is this inequality correct or not? 0 is greater than -1? Yes, it's true. So the shaded part is going to be the part with the point that we had, which is 0, 0. So this will be the shaded part. Okay, let's check our solution we have. So here, yes, they substituted 0, 0 into the equation and they got 0 greater than -1, which is true. So shade the half plane that includes 0, 0. That's right. So we shaded this part. That's correct. Now let's go for the second problem we have. What is the graph of each inequality? Y less than or equal to 3x minus 1. Okay, let's solve it together. Okay, here. So it's going to be the same graph because it's the same inequality, but the only difference here that we have less than or equal to. So we have the equal here. So it's going to be a line without dashes, right? So it's going to be somehow a line without, this way, a line without dashes. Okay, now let's check which part to shade. So we're going to substitute 0, 0, 0, 0 into the equation. So it's going to be 0 less than or equal 3, 0 minus 1. So 0 less than or equal to -1. Now 0, is it less than or equal to -1? No, it's not true. So we're going to shade the part that does not include this point, which is the other part. So it's going to be this part. Now let's check the solution. So here it's going to be okay, so here it's going to be, we substituted 0 and 0. Since 0 is less than or equal to -1 is false, 0, 0 is not part of the solution. So we're going to go to the other half to shade it. Okay, now let's go for another problem that talks about graphing linear inequalities. What is the graph of the inequality y less than, greater than or equal to -2x plus 1? Okay, so let us solve this here. So it's gonna be as this line, a straight line without dash, because here we're gonna have the equal sign. So and you know how to find to graph the line itself. Now we're going to check to put the to shade this half or to shade this half. So we're going to substitute 0, 0 into the equation. We're going to substitute 0 here and 0 here. -2 times 0, which is 0. So 0 greater than or equal to 1. Is this correct? False. Because 0 is greater than 1, but 0 is not equal to 1. So this is, 0, it's neither greater than nor equal to 1. So this is false. The side containing 0, 0 is not part of the solution, so we're going to go for the other part to shade it. Okay, up to here we're done with knowing how to graph the linear inequalities and which part to shade, right? Now let's go for the second idea we have in this lesson, which is graphing an absolute value inequality. Now let's remember the graph for the absolute value was, what's wrong here? Okay, the graph for the absolute value was the V shape. Do you remember it? So it's going to be, the solution is going to be a V shape, either downward, upward, to the left, to the right, okay? So now let's check this question. What is the graph of 1 minus y less than the absolute value of x plus 2? Okay, let's solve it together. Okay, so first of all, we have to make it as y less than or greater than to whatever. So we're going to leave y alone. So we're going to move 1 to the other side. It's going to be -y less than x plus 2. Then we're going to move it, this is going to be -1. Now here we're having negative, so we're going to move the negative over there. So it's going to be, when we move, as if it's -1. Okay? So when we move a negative, when we move a negative, like as multiplication or division, we flip the sign that we have here. So it's going to be greater than negative. We're going to multiply -1 with this and -1 with this. So it's going to be as -1 x plus 2 plus 1. Okay? Now we have to graph. Let's have a quick graph here. Okay, so first of all, instead of like graphing, if you want, just let's have it as the origin. So the origin absolute value graph is the V shape with the origin of 0, 0. Now let's think about like the translation or the transformation that we got here. Do you remember the transformation from the previous lesson? So here it says, as if it's a reflection, it's going to be as y greater than negative x plus 2 plus 1. So first of all, here we have negative, so it's going to be a reflection of the y-axis. So it's going to reflect on the y-axis. It's going to be this way. It's going to be this way. Then we're moving it 2 units horizontally to the left because it's positive, so we're going to move it to the left. So it's going to be as it's going to be 1, 2, so it's going to start with over here. It's going to be this way. Then we're going to move it 1 unit upward. So it was supposed to be here, so we moved it 1 unit upward, so it was like this way. This is the transformation that we got. Okay, so now we have this. Shall we shade the upper part, this part, or shall we shade this part? How shall we do this? We're going to substitute 0, 0 into the equation, right? It's going to be as, okay, just a second here. Let me write it over there. Okay, so now let's substitute 0 into the equation as the points 0, 0 into the equation. It's going to be as 0 greater than negative 0 plus 2 plus 1. It's going to be as 0 negative 2 plus 1, 0 greater than negative 1. Now, is this true? 0, is it negative? Is it greater than negative 1? Yes, it's true. So we're going to just, let me remove these two. I want to just, oh, sorry. Okay. What's wrong with this? Okay, خلاص, I don't want to remove it. It's fine. So now let's shade the part with the 0, 0, which is going to be all of the part that we have here. This is going to be the shaded part that we have here. Okay, let's check our answer. So they did here, first of all, they moved everything away from y, then they divided by negative 1, they changed. So this is the equation that they got. It's the same as ours. Then they graphed the line here. Oh, I forgot, it's going to be shaded line because it's without an equal sign over here. So it's going to be a shaded line. Okay, the graph of y is the graph of y equals x, but then the reflected in the x-axis and translated 2 units up, 2 units to the left and 1 unit up. That's right, as we said. Since the inequality is solved for y and y hada, shade the region above the boundary. Obviously, greater than, it's going to be greater than this, or you're going to substitute 0, 0 into the equation. Okay, let's have another example here, which is what is the graph of y minus 4 greater than or equal to 2 in the absolute value x minus 1. Okay, let's just have it here. We're going to move the negative 4 over there. It's going to be as y greater than or equal to x minus 1 plus 4. It's the same as if you want to use the transformation to do it, or you're going to make a table of x and y values. Now here he shaded this, and greater than or equal, either by logic you're going to shade this part, or you're going to substitute 0, 0. Let's try substituting 0, 0 into the equation. It's going to be as 0 greater than or equal to 2, 0 minus 1 plus 4, 0 greater than or equal to 2. What's the answer? It's going to be 1 because it's an absolute value, plus 4, 0 greater than or equal to 2 times 1, 2 plus 4, 6. Now, is 0 greater than or equal to 6? No. So we're going to shade the part that does not include the point 0, 0, which is this part. Okay? Now, let's go for the last point we have for today, which is writing an inequality based on a graph. What inequality does this graph represent? Okay, so we're having this graph, and based on this graph, we're going to make an inequality. Let's solve it together. Okay, so from this graph, we have to know the inequality that we have. So let's just think about the equation here we have, which is y of the absolute value. Y equals absolute value of x. This is the original one, right? Now, based on the vertex here, we're going to see what transformation happened. Actually, here only translation happened. So let's see here. It's going to be, now we have the vertex 3, negative 2. So h is 3. So it's going to be as h minus 3. Then we have negative 2 as k, negative 2. So this is the inequality. This is the equation, I mean, that we got. Now we're going to think about if it's going to be greater than or less than, or greater than or equal, or less than or equal. How are we going to know this? Since obviously the graph here is above or on the top of the V shape or the V boundary that we have, it's going to be greater than. Okay, so let's put it in our minds that because it's above it, it's going to be greater than. Greater than x minus 3 minus 2. Now to check if it's greater than alone or greater than or equal to, we're going to see the boundary that we have. Is it dashed line or a simple line? It's a dashed line, so it means going to be greater than, not greater than or equal. So this is going to be our answer. Let's check our answer together. So here, first of all, they use the vertex that they have here, and they just plotted the transformation that happened, which is y equals x minus 3 minus 2. The solution is shaded above the boundary, so inequality is either greater than or greater than or equal. So as I said, when it's above it, it's going to be greater than. When it's below, it's going to be less than. That's in the absolute value, okay? Since the boundary is a dashed line, the correct inequality is greater than. That's right, so it's going to be as greater than. Okay, so let's have one more example here for this. What inequality does this graph represent? Let's solve it together. Okay, so now we're going to find the inequality from the graph. So first of all, what's the vertex of this? It's going to be, as here they're moving by 2, so it's going to be -4. The vertex is going to be as -4, and here it's going to be somehow 3. Okay, so it's going to be the vertex -4, 3. So from the vertex that we got, we can find the equation here, which is y x minus minus, which is +4 plus 3, right? Now here we can see that it's inverted. The V line or the V shape here, it's inverted, so it's going to be as reflected. It's reflected on the x-axis, so it's going to be as negative x plus 4, as if the y values change. So this is going to be the equation that we have. Let's make it as an inequality. Let's think now. First of all, because it's going to be above the line or above the boundary, it's going to be greater than. It's going to be either greater than or equal, right? Now we can check if it's greater than or equal by looking at the boundary line here that we have, which is a dashed line. So it's going to be greater than. So here y is greater than negative x plus 4. This is x plus 4 plus 3. This is going to be the inequality that we have after transformation. Let's check the answer. So here it's going to be the boundary in the graph reflected across x. That's right, the vertex is translated -4, 3. So the boundary is going to be, this is the equation, y equals negative x plus 4 and the absolute value plus 3. The shaded region is above, so it's going to be either greater than or equal. Because here the boundary is a dashed line, so it's going to be the greater than sign. This is the answer as we got, which is correct. I hope everybody understood, and have a nice day.